Okay, so accelerated math analysis. We're still in section 1.4, but worksheet 1, that was, I believe, just that one-sided worksheet that we had done the previous day. So for number 35, some directions are to find the vertical and horizontal asymptotes. And you might wonder what that has to do with calculus and with limits. And it certainly does have something to do with that. We're going to see that in just a moment. But the function that we're asked to work with is f of x equals x plus 4 all over x squared minus 16. And guys, what you're going to see is you've already dealt with a problem like this in August. You know, we started the year really dealing with a lot of pre-calculus, and we dealt a lot of time. We spent considerable time finding vertical asymptotes and horizontal asymptotes. Now, what you probably remember is a good adage is to factor first. What can we factor down below? What would we get? X plus 4, x minus 4. Now, from here, we can talk about vertical asymptotes. Vertical asymptotes, guys, are going to occur as you're dividing by 0, but we have to be careful. Vertical asymptotes are lines. What do you think our equation of a vertical asymptote might be? X equals 4. What about negative 4? No, you might remember from previous work that when things cancel out, you get a whole. Now, they're not asking you to name that, but it's a good practice to do so. By the way, when we get to section 1.5, where we talk about continuity, one of the things we're going to talk about will be removable discontinuities, also known as wholes. So you can cancel this out. We're not dealing with a vertical asymptote there, but you might remember, my gosh, how do I find the y-coordinate? You know, if you looked at the reduced equation, y equals 1 over x minus 4, then if I plug in x equals negative 4, and by the way, we could do that by writing a vertical bar. You're going to see that a lot in mathematics. You'll see a vertical bar. By the way, plug x equals negative 4 into that. Then we'll have negative 4 minus 4. That's going to be a 1 over negative 8, but we can just write negative 1/8. So that's your removable discontinuity. That is your whole. Of course, if I plugged in x equals 4, I'm dividing by 0. That would be something excessively large. That's going to be your vertical asymptote. Okay, everybody doing okay? Well, you might think, well, what about finding the horizontal asymptote? Well, guys, the horizontal asymptotes are lines also, but they occur as x gets to be exceptionally large. Now, of course, we've already factored this, but you don't even have to have factored it. You could have found your horizontal asymptote first, in fact. And you might remember, as we dealt with limits as x went to infinity, we multiplied the top by the reciprocal of the highest power below, or we're dividing everything by the highest power below. That's what? X squared, right? So you could say, well, I'm going to divide by x squared and divide by x squared. And, you know, when you do that, that's really saying multiply everything by 1 over x squared. So you'd get x all over x squared. Here's a 4 all over x squared. Down below, I'll have x squared over x squared. And here I'll have a minus 16 over x squared. And if we reduce, if we just, you know, finish that off a little bit, x over x squared is 1 over x. That reduces a little nicely. Down below, x squared over x squared, hey, that's just a 1. But tell me about this numerator. Both of those are going to 0 as x gets to be really big. Down below, I'd have 1 minus a 0. Guess what that is? 0. Now I'm going to make a mistake for my horizontal asymptote. I'm going to say, yep, the horizontal asymptote is 0. No, you see, it's a line, isn't it? A line has an equation. You might remember Vux and Hoy. If you're going to write the equation of a horizontal line, you got to have y equals a number. You write a vertical equation of a line, you're going to have x equals a number. You'd say, what about the u there? Well, that's undefined slope. This is 0 slope, right? Friendly little memory device to help you with vertical lines and horizontal lines. And guys, you're done. You're done. So that's answering something like number 35. But I want us to take a look also at a problem that is a classic calculus question. We're going to take a look at, say, number 39. And number 39, the directions say, a function satisfies the given conditions. Sketch a possible graph. So they want us to sketch a possible graph. And big assumption, assuming f does not cross the horizontal asymptote. Okay, so they're giving us these guidelines, but then all of a sudden they give you this plethora of information. They're going to say the limit as x approaches negative infinity of f of x is -2. The limit as x approaches positive infinity of f of x, that equals -2. They're telling you the limit as x approaches 3 from the left of f of x, that goes to infinity. The limit as x approaches 3 from the right goes to -infinity. Wow, they're not done. They're going to say the limit as x approaches -1 from the left goes to -infinity. And then finally, the limit as x approaches -1 from the right, that goes to positive infinity. And, it's very natural for us to say, well, tell me what f of x is. What's the equation? Oh, no, that's the challenge. We don't know. They're not going to give us the equation of f of x. They're just giving us 6 limits to help you. And then they're saying, would you tell me what this graph now looks like? Wow. Well, if you really think about it, guys, you can do this and it's not that bad. If you're thinking about the first 2 limits that they're giving you end behavior. They're giving you end behavior. Now, as you look at that, why do we call it end behavior? Well, at the end of this right x-axis here, x is going to positive infinity. Here's the end of the left part of the x-axis. We're going to negative infinity. They're saying either way, your y value goes to -2. What does that really tell you? You've got a horizontal asymptote of y equals -2. Wow. Make a dotted line there. And no doubt, I'm sure kids are going to say, well, that's not enough. I mean, you could have billions of graphs that have that behavior. I don't know what else is happening. Well, wait, they give you some more. They're saying as x approaches 3 from the left and x approaches 3 from the right, you go to positive infinity and negative infinity. What do you think is going to be present there at x approaching 3? A vertical asymptote. Now from here, I'm going to change color and I'm going to say, look, 3 from the left side, like at 2.999, you're going to positive infinity, right? And then you'd say, well, 3 from the right, something like 3.001, you're going to negative infinity. Oh, look at that. I can show the behavior around the vertical asymptote, right? But there's more information. Kids are going to say, no, wait, there's also at -1. Now, at -1, you might guess we've got another vertical asymptote. And you could say, well, from the left side, we're going to be approaching negative infinity. From the right side, we're going to be approaching positive infinity. And guys, right now, maybe, just maybe, we have enough pictured where we can graph this thing. You see that? Here's the other important aspect. You don't cross the horizontal asymptote ever, they're saying in this problem. Okay? Now, to be sure, kids could say, aren't there still a whole bunch of graphs that you could make? Yeah, you're right. You could make a whole bunch of graphs. But still, in general, in this lower right-hand portion, if I'm not going to cross a horizontal asymptote, would you agree you'd have to have what I just traced in? And now you look in the middle between -1 and 3, and I'm not going to cross my horizontal asymptote. And sometimes kids will say, well, Mr. Dobner, where do you know where to put the x-intercepts? That's your degrees of freedom, right? I don't know where I'm crossing the x-axis there. I don't know those zeros. So, somebody might say, I didn't draw it quite where you did. But as long as you've got that general shape, you're communicating what's happening, right? They're asking for a possible graph. Even the wording is implying that there might be more than one answer, right? And then likewise down here in this lower left-hand portion, if I know I can't cross my horizontal asymptote, that little portion down on the bottom left has to be that type of behavior. We doing okay? All right, so that's the quote-unquote new stuff, and I hope it's not bad. So we're not going to, your homework for Monday is going to be the 1.4 worksheet 1. That's not what we did, for homework today. It's the homework that we did the previous day, the one we checked in on Thursday. But we're going to do numbers 12 through 40, the evens. Okay, so hopefully you can have a lot of time for that today.